right, so the next lesson in this unit is kind of like a 2-day process. We're going to start with one type of quadratic equation, and then tomorrow we'll look at kind of a different case. All right, so there were a couple questions on your homework for the factoring that looked something like this, like x squared plus, I think it was 8x plus 16 equals 0, and you had to solve that. Well, when you factor it, you got the same two factors. X plus 4 times x plus 4 equals 0. All right, well, this is something called a perfect square trinomial because we can really write this as x plus 4 quantity squared equals 0. There was another one that I think was x squared minus 10x plus 25, or like I said, something along those lines. And you factor and you get x minus 5 times x minus 5. All right, so when you have the same two factors, again, that's called a perfect square trinomial. So what we are going to do is take equations that aren't perfect square trinomials and that can't be factored and make them into perfect square trinomials. Okay, so on your notes, that's kind of what this first little part illustrates. It says factor the following: x squared plus 2x plus 1. And we're just factoring. I just want the quantities that are in parentheses. We're not going to solve quite yet. So when we do this, we're looking, okay, what two numbers multiply to 1 and add to 2? Okay, well, that would be 1 and 1. X times 1, or x plus 1 times x plus 1. What two numbers multiply to 9 and add to 6? All right, well, that would be 3 and 3. Okay, what about this one? Oh, we just did that. X minus 5 times x minus 5. Okay, so the reason this is, I got some old school algebra tiles right here. So if this little square represents my x squared, because it's a legitimate square, so x times x, the area of this is x squared. And then I'm going to pretend that these are my two x's. And this little guy, that's my 1 right here. Okay, so the reason this is called a perfect square trinomial is because I can take these 4 little pieces and create a perfect square by taking this piece up here, this piece adding it to the side, and then that piece in the corner. And I've created a square because every length of each side is the same. You can do the same, like if I had x squared, and then if I take 4 of these, okay, and then 4 of these little guys. So x squared plus 4x plus 4, I can create a perfect square with that because I can take 2 and 2 and then fill it in with this little section right here. So notice the area of the square that I'm like adding to literally complete the square there is 2 times 2. And then I've completed my square. Okay. So if I think about what I would need to add here and here and here to make this a perfect square trinomial. So we're not going to worry about the positive and negative yet. And I don't have enough tiles to do the 14. But if we think about kind of what we did, when I did x squared plus 4x, well, the way that I completed the square was I took these 4, I guess, and I split them in half and added them to either side. And then again, I added these 4 squares here. And the reason there were 4 of them, the area of the square is 4 because it was 2 times 2. So if we can picture, okay, if I had that x squared box and I've got 14 x's, well, that means that I would take 7 of these. I don't have enough, so you guys get the idea. And 7 of these. And then I'd have that square up here. And the area of that square would be 7 times 7, which is 49. So then that would be x minus 7 squared. Same thing here. Okay, if I've got 12 of these, well, to complete the square, I would put 6 on the top, 6 on the side, and then the area of the square that I would use to complete that, 6 times 6 is 36. So then that factors to x plus 6 squared. This one, if I've got 24 of these, I'd split that up to 12 and 12, and then the area of that square would be 12 times 12, or 144. And then that would be x minus 12, quantity squared. Okay, so this is the situation that we are trying to create here. Okay, so let's take a look then at how we would solve a quadratic equation by completing the square. So we're going to take a look and we're going to start with one that it could be factored if you wanted to do it that way, but I just wanted to show one that kind of worked out nicely for our first example. All right, so x squared plus 2x minus 3. It is not a perfect square trinomial. If we were to factor it, it would be x plus 3 times x minus 1. Okay, so that's not a perfect square trinomial because these two factors are different. All right, so what we're going to do now is kind of like this step right here. Okay? So I'm going to start and I'm going to get rid of that 3. I'm going to move it over so it's out of my way. So x squared plus 2x, and then I'm going to leave a little bit of a blank here because I'm going to complete the square for these two terms. And then when I move that over, that becomes a 3. Well, if I'm going to be adding something over here, my equation now is unbalanced. Okay, so whatever I add here, I have to add here. Okay, so now I'm going to think, all right, well, what would I need to complete the square? So if I have my 1x squared and then my 2x's, okay, well, I would split these apart. And then the area of what I would need to add would be 1 times 1, which is 1. Okay. And so whatever I add over here, I have to add over here. So now this factors to x plus 1 squared equals 4. So now from here, we solve by taking the square root of each side because I'm trying to break this out of the parentheses. I'm going to take the square root of each side. What we have to remember here is that when you are solving by taking the square root, you get a positive or a negative answer because you're really asking yourself what number to the second power is 4. Well, positive 2 squared is 4, negative 2 squared is 4. So from this step to this step, you always will make it positive or negative. Every quadratic equation has 2 solutions. Okay, sometimes it's a double, like we got when we solved ones like that. So your answer was essentially just -1 twice. But every quadratic equation has 2 answers that are driven from this plus or minus. Okay? And so now what I'm going to do is subtract 1 from each side. So -1 plus or minus 2. And then in this case, I can go ahead and simplify that since I don't have any radicals involved here. So -1 plus 2 is 1. -1 minus 2 is -3. And that would be our answer. Okay. Now, if you were given the choice to solve this however you wanted to, obviously completing the square is probably not going to be the most effective method. It would be much easier to factor that. You guys could probably do that in 30 seconds. Okay. But again, I wanted to show you one that worked out a little bit nicely. All right, so now if we look at this one, okay, so if I start by thinking, okay, can this be factored? Are there two numbers that multiply to 8 and add to 4? Okay, well, I don't know. Actually, I'm going to change this to be minus 8 instead of positive 8, or else I forgot we hadn't got to imaginary numbers yet. So just change that to a negative here. Okay, so same question though. Are there two numbers that multiply to negative 8 and add to 4? No, not possible. Okay, so we can't factor this one. So this is where completing the square could actually turn out to be really helpful. So I am going to move this 8 over here. So it's become positive. And then I'm going to create a situation that I can factor this now. So I need to figure out what I need to add to each side to complete the square. So if I've got x squared plus 4x. All right, so I know I'm going to split these. And then the area of this square that I would need to create would be 2 times 2, which is 4. So I'm going to add 4 to each side. Okay. Now this would factor to x plus 2 squared. X plus 2 times x plus 2. And then 8 plus 4 is 12. So from here, square root each side. That cancels out over here. Always put the plus or minus here. And now we do have to see if we can simplify this radical. 12 is not a perfect square, but if I think about perfect squares that go into 12, I think of 4, and then I have that 3 left over. So the square root of 4 is 2, and then I have that 3 left underneath. And then to get the x by itself, I would subtract 2 from each side, and that would be my final answer. Negative 2 plus or minus 2 radical 3. Okay. All right, let's take a look at this one. So if I start here, I'm going to work on completing the square. So I need to move my constant over. And then I'm going to add something there to complete the square. 18 minus 9 is 9. And then I'm going to have to add to keep my equation balanced. All right, so let's think here. I think I have, yep. So if I've got 8 x's, we're just going to, again, pretend they're positive for this. We'll talk about why you always are adding a positive in a second. So if I've got 8 x's, if I want to make a perfect square, I need to add 4 up top and 4 on the side. So the area of the square that I would need to add to complete this square would be 4 times 4, or 16. So a question that I get a lot is, well, why is this always positive even though sometimes this is negative? Well, it's because this number represents the area of the square, this pretend square that we're adding. And the area of something cannot be negative. So even if this is negative, you will always be adding a positive number. Again, because that represents area. Area is never going to be negative. So this will simplify to x minus 4 squared. 9 plus 16 is 25. Square root each side. That cancels. Positive or negative, square root of 25 is 5. So when you see a perfect square here, that means that this equation can be factored. So again, that's probably going to be your more efficient option if you're not being forced to complete the square. All right, so add that 4 over. So 4 plus or minus 5. 4 plus 5 is 9. 4 minus 5 is -1. So those would be my two solutions. Okay, let's look at one more. And again, let's change this to 10. Let's change that to 10. All right, so there are no two numbers, again, that multiply to -10 and add to -2. All right, so I can't factor it. Completing the square at this point is the only other option that we have. I'm going to add the 10 over so I can complete the square on the left. All right, so if I've again got x squared, and then I've got my two x's. So to complete my square, I'll split that middle term in half. The area of the square that I would need to add, 1 times 1 is 1. Okay. And so then this will factor to x minus 1 squared equals 11. And so when I solve by taking the square root of each side, that cancels this over here. Plus or minus square root of 11. This cannot be simplified. There is not a perfect square that goes into 11. So that means when I add that 1 over, my final answer would be +1 plus or minus the square root of 11. Okay. So one of the things that I honestly see a lot on student work is honestly kind of like a drawing of this. Like, well, I don't have algebra tiles. How do I do this? And what happens if I don't have enough? Well, unfortunately, I do have a class set, but I can't let you guys touch things this year. So if I were to give you a problem like x squared plus 16x minus 10 equals 0, well, that's not factorable. Okay. And so if you don't have algebra tiles, you can just kind of draw the situation. Okay, so say, all right, I know I'm going to have that x squared. And then if this number is 16, that means that this and this would both be made up of 8 of those x's. And 8 times 8 is 64. So you can kind of draw that square off to the side. And then you would go from there. Factor it, be 74. Square root x plus 8 equals, I don't think there are any perfect squares that go into 74. No, 16 nope. So that means you can't simplify it. It would just be positive or negative radical 74. And then, and then subtract that 8. So -8 plus or minus the square root of 74. So seeing this visual will help tremendously as you are getting through these. Okay, so tomorrow in class, we will kind of talk about, all right, what do we do when this is odd? Or what happens when this is not 1? Does that change anything? And so in the meantime, if you have any questions, just let me know.